Hello, and thank you for taking time out of your valuable schedules today. I'm Doug Lambert. I'm the MultiSpeak Program Manager. I took over this role in August of 2013 with the retirement of Bob Saint from InterECA. In my previous life, I spent 21 years working at electric cooperatives, implementing many progressive technologies. And today, I'm going to tell you the story of one of those cooperatives' journey of implementing the MultiSpeak interoperability standard. I served as the IT manager for San Bernard Electric. In that role, I was responsible for the IT, data processing, GIS mapping, and SCADA dispatch departments. This unique combination of responsibility is what made the following success story possible. Let me start by explaining a little about SBEC. They are a distribution electric cooperative in southeast Texas with 26,000 meters. They're 96 miles long by about 35 miles wide. They have 78 miles of transmission with 16 substations with SCADA control and monitoring with a 24-hour dispatch. They have 4 offices covering 7 counties, and they have a microwave backhaul between their offices and substations. You can find out more information from their website. In the early days, a lot of customization was required to shovel data from one system to the other. We had a spider web of custom solutions. Over time, technologies evolved, requiring even more customization. Finally, we began to realize the need for standards and data interoperability. This was when I was first introduced to MultiSpeak and saw the light. We began our journey of untangling the spider web of data and replacing each process with MultiSpeak. Now, MultiSpeak does not answer all of our integration needs, but we are utilizing it where it does. Where it does not meet our needs, we're talking with the vendors and with the MultiSpeak organization to see if future development can fill those gaps. In some cases, the functionality exists within the use cases and endpoints of MultiSpeak, but the vendor has chosen not to support the particular business process in this manner. We're using batch processing in some cases. For instance, the ship file that comes with each shipment of meters, it's batch dumped into the inventory system. The meter exchange follows a similar process as we deploy to the field. We have a daily interval reading that batch uploads to the billing system. This was done with a custom query and scheduled task inside of SQL. For our MDMS, we take advantage of CMAP and MLA standards. Alarms are sent over to our outage management system and field viewers through some custom SQL that I wrote. Blink counts are gathered and stored as daily readings to a SQL table. I run some deltas against the blink counts and compare them to outages in the area to determine action needed to improve the quality of service. For all of this to work like one well-oiled machine, I had to become intimate with all of the enterprise systems, the business processes, and the data exchanges that were necessary. We have been successful at using MultiSpeak to improve processes and save money in many ways. Our disconnect non-pay from our CIS reports live updates to our OMS. This prevents wasted and unnecessary trips by linemen on false outages. Account status changes, service location changes, meter changes, and posting of outage calls are all made possible from our CIS to our OMS using MultiSpeak. This allows the customer service representatives to remain in the software they are accustomed to and still provide pertinent information to other departments and systems. Staking, also known as field engineering, to engineering analysis and mapping GIS processes have been simplified and improved in accuracy by automating with MultiSpeak. Phone number changes can be updated from our OMS to our CIS. We've improved customer service and reduced training necessary by presenting billing inquiries to the dispatchers within the OMS from the CIS using MultiSpeak. SCADA can automatically report lockouts to our OMS using MultiSpeak. However, I should note that we have discontinued this tie temporarily pending a security audit. When we had our AMR powerline carrier system, we could ping meters from within the OMS to see if they were out of power. This allowed us to determine the extent of an outage with fewer phone calls. It also eliminates wasted trips and improves customer service by verifying a single outage by verifying a single outage and if it's beyond the meter. If a single customer calls in with an outage, the dispatcher was instructed to ping the meter while keeping the customer on the phone. If the meter came back as on, we would instruct the member on how to check their breakers. We would still send a crew if the member insisted. However, we would charge a trip fee if we arrived and only flipped breakers to resolve the issue. This one MultiSpeak implementation has saved the co-op thousands of dollars in wasted trips. The recently implemented AMI radio frequency system is two-way. We no longer have to ping meters to check its status. The meter automatically reports outages lasting longer than 64 seconds to the OMS. We are also made aware of theft or meter tampering within 6 seconds of it happening. All of this is possible by the magic behind the curtain known as MultiSpeak. Today, we are using some custom SQL integration to capture alarms on power quality issues. I will get into that later. Time will not allow for us to take the deep dive on every area where MultiSpeak has been implemented at our utility. So, I will focus on one. Our most recent project was implementing an AMI RF two-way system to replace our AMR powerline carrier system that had been in place since 1988. We formed a committee from each of the internal stakeholders and departments that would or could possibly be affected by this project. I focused in on making sure we were able to leverage all the data from the AMI and not lose any of our existing capabilities. This included synchronizing the changes and information from our CIS and AMI, as well as our OMS and AMI using MultiSpeak. In the next few slides, I will show the interaction between our outage management system and advanced meter infrastructure systems. This is an example where every meter called in within the first 2 minutes to the outage management system. Notice we have no calls or IVR calls as of yet. Only meters have told us exactly which device is open. The meters have a programmable capacitor that allows us to adjust the amount of time a meter should see zero voltage before reporting it as an outage. We need to give our reclosers time to do their job and not report momentaries as outages to our OMS. We have set our meters to 64 seconds. By making minor adjustments in the AMI system, improved reliability in the data resulted. This was a joint effort between departments to achieve the desired results. Here's that same outage after the restore. Notice the truck is still on the scene, as we can see that with live AVL integration, making for a safer work environment. We only received 2 phone calls. One is manual, shown in red, and one is through the IVR, shown in blue. However, every meter told us their power had been restored. MultiSpeak made this possible. The more information you can feed the outage system, the better the prediction engine can function. With only phone calls, this outage would have taken much longer to determine the fuse was open. We might not have known until the crew arrived on scene. This video will demonstrate using the model connectivity on how to ping all meters downstream from a protective device. The amount of time it takes to get the meters to respond to a ping will vary depending on the backhaul and network traffic. I've pinged as many as 500 and received answers from all the meters within 90 seconds. Then I've pinged those same 500 and it's taken as long as 5 minutes, with 50 plus meters timing out because of the network traffic and because of the network being busy. It's important to understand the behavior of your systems to get favorable results and to trust the information being presented. Here's yet another example of meters calling in before we received a single phone call. This particular outage also had a SCADA device report the lockout. Notice, there are no phone calls yet. Only meters telling us they are out. This was about 90 seconds into the outage. Here, not all the meters were successful at reporting the outage to the system. But we didn't really need to hear from every meter to know the full story of what had happened. When we first turned on MultiSpeak, between the AMI and OMS, we were getting alarms posting as outages on the outage management system. Obviously, this is not good. We have to be able to present the data to the dispatcher in the right manner every time, or he will lose trust in the systems, and rightfully so. I blame this on untested interoperability between the vendors. The AMI vendor was quick to act and correct the problem by setting the meter alarms, or also known as meter events, to an NR state, or no response, in the MultiSpeak message payload. However, the OMS vendor was unable to digest that NR data. This left me with a problem. We needed those alarms. The alarms were one of the deciding factors in choosing this AMI technology. Time to put on some more Band-Aids. Some of the information was coming over correctly from our AMI to our OMS using MultiSpeak version 3.0. Where it was not, I had to write some custom integration. Our AMI vendor was using a SQL database. I had to discover which tables were storing the alarms. Then I had to understand the behavior of the AMI system and the value of each alarm. I had to understand the tables and the behavior of the OMS as well in order to update the correct tables with SQL commands to display the desired results to the OMS in a desired manner. This took the cooperation of each vendor, a lot of knowledge of SQL, access to the right tables in the right manner, and a very patient group of employees. I had to then train the dispatchers in understanding the alarms and taking the appropriate action. When is too much information not helpful? For instance, we were seeing brownout alarms with almost every outage event. During a lightning storm, the dispatcher's OMS screen would be covered with brownout alarms that were simply dismissed as being related to an outage. I quickly turned that alarm off. However, that also meant we were going to miss those alarms when they weren't related to an outage. All of this interpretation was left up to me to determine and to work out. What if I missed something that was important? It was too complicated and cumbersome to dig through all the alarms in the AMI system and trying to do something with them, and it wasn't real time all the time in the AMI system either, and it was 1 meter at a time. I wrote some SQL code to look at the alarms view in the AMI database and present them as a note on the screen. The note is given an immediate expiration date and time, and the dispatcher receives an audible alarm as well as a symbol on the meter on the connectivity model within the dispatch outage management system. In this example, the dispatcher received all of these alarms at the same time. They were all high voltage alarms, all on the same phase, A phase, and all downline from a regulator on the connectivity model. A crew was dispatched to the regulator, where they discovered the regulator controller had indeed gone bad and was outputting high voltage. The regulator was taken offline and the problem was corrected. From the moment we received the alarms until the problem was corrected was less than an hour. No phone calls were received. Just a few months prior to implementing this particular integration, SBEC had a similar incident. We were not made aware of the high voltage until receiving calls and complaints from our members. Once we identified it to be faulty equipment on our line, we received multiple insurance claims that we had to pay. This is a great example of where investment into the smart grid and interoperability of normal disparate systems provides some return on that investment.